Hi, welcome to Architectural Design and Advanced 3D CAD. This is the second course in a 3-credit design and drawing sequence. The first course, which everybody has completed, was Design and Technology. Here we are in year 2, followed by Advanced Design and Innovation. Now, what's very different this year about architectural design is I have pulled some concepts, the Advanced 3D CAD stuff, I've pulled that from the third year course, brought it into the second year for kind of a hybrid class of half architectural design and half advanced 3D CAD. So I'm really excited to roll this out this year. So I'm going to walk you through what it is the students are going to learn and in what order. So starting with architectural design. So for the first half, we're going to be focused on mostly residential structures. And when we talk about architectural design, I like to think of it as both the science and the art of designing structures. So for the science side, we're kind of sticking with tried and true suggestions and guidelines as put forth by the Federal Housing Administration. So when we're designing our houses, we're sticking with certain standards, making sure that our hallways are at least 3 feet wide, making sure doorways are at least 6'8" tall, making sure we have a functioning work triangle in the kitchen. So that's the distance traveled from the range to the sink to the refrigerator and back, making sure that that's unencumbered and making sure that the distance traveled from those 3 areas is not greater than 21 feet. So we have these parameters and guidelines that we all stick with to give us the best chance of having a functioning house that really flows well. Where they have a lot of freedom, though, is in the configuration of their houses, the materials that they choose, the textures that they use, the colors, and the combination of those things. So it's really a great class that allows for creativity in that sense. So our first TLA, which is a technology learning activity, which we haven't gotten to yet. We're still playing catch up a little bit from last year. So right now the students are learning AutoCAD. It's the 2D drafting software that we use. We went remote last year, like right around the time that we started this. So we're getting everybody caught up. And soon enough, we're going to be designing our first house. And that first house is a lake house. It's going to be along Lake George. And they are working within certain parameters or constraints. The house cannot exceed 1,000 square feet. It's going to be a 2-bedroom, 1.5-bath minimum with an eat-in kitchen, living room, place for laundry, storage, making sure there's plenty of closets, and of course accounting for the view for the lake. And what's really cool about the way that we design the houses, but also the software that we use to show those designs, is that when we go into 3D, which we're going to be using a program called SketchUp that the students are already familiar with. We're going to be taking SketchUp to the next level in this course. So what's really cool about SketchUp is we have this feature where we can integrate our models with Google Earth, and we can geolocate our models. So what the students are going to do is once they've designed their houses, they're going to be able to bring it into a 3D environment. And actually through Google Earth, they'll be able to import their house in a location along Lake George, and we'll be able to actually toggle on the terrain. So whatever that topographical layout is of the land that they choose anywhere along the lake, they're going to have to modify their foundation height and steps leading up to their foundation and their decks to all kind of be conducive to whatever that terrain is. So it's really a true to life problem that the kids usually have a really good time with. Now, our next challenge, which is really very much a spatial problem, is the micro home. Now, in this case, students are designing a house to accommodate a family of 4 that has to fit within the confines of a parking space. So it's 9 feet wide, 18 feet in depth, and 30 feet tall. So we're really building up, not out, with this project. It's a spatial problem, it's difficult, and when they're done, they're always happy with the result. So I'm really looking forward to getting into this project this year as well. And to kind of supplement some of the content that's not being covered in the way of projects, we're going to be introducing in more formal lessons construction systems. So we want the students to walk away with an understanding of how houses come together, because how can you really design a house if you don't understand how houses are built? So we'll talk about foundation systems, roof systems, framing, all those things that students should have a basic understanding of to really be designers. When we're finished, my goal, as always, is my goal for these courses is for students to be able to walk away with a professional quality portfolio. So they're going to have a portfolio of their work that they can carry with them to the next course, and that they'll feel comfortable and confident submitting to a potential college or a potential employer. Changing gears for the second half of the year, we're introducing our advanced CAD software. This is called SolidWorks. It's parametric modeling. The things they can do in SketchUp are great, but they don't hold a candle to what they can do in SolidWorks. So this is, real deal professional engineering quality software. This is what all the roller coasters in Six Flags, they're all designed using SolidWorks. Many, many consumer products are designed with this software. So we're going to really learn the ins and outs of this. Apart from a portfolio, the other goal that I really hold for each of these students is the opportunity to take and pass the CSWA exam. So it gives them the opportunity to become certified SolidWorks associates. It's a very difficult exam. I'm really excited that we have an opportunity to dedicate half a year to really learning the ins and outs of the software, and I think our passing rate is going to be higher this year than it ever has been. When I tell you that it's difficult, I mean it. And because of that, their performance on the exam has no bearing on their grade for the course. I just want them to have a chance to take it. So it's a 3-hour practical exam. They don't have to pay for it. They can take it in class with me. Well, not in class because it's 3 hours, but in the room with me, or they can do it remotely this year, as is going to be the case for many of the students. But I really am excited to have the opportunity to focus and dedicate half a year to this software, because I think our passing rate is really going to go up as a result. So, it's not just going to be test prep the whole time. We're going to be learning this software, and then I want to apply what we've learned into some fun projects. So something we haven't done in the past, at least not at the high school level, are CO2 dragsters. It's a really fun, classic technology education project. But what's going to be different about this is they're going to be designing their CO2 cars digitally in SolidWorks. They're going to be printing out the side and top views of their car, and we'll be gluing them to the block of wood that you can see on the left here. And then we'll be able to actually go ahead and cut these out and recreate what we've seen on the screen and what it is that we've designed, but we're going to be able to recreate it in real life, test the cars, race them. I'm still figuring out the logistics of that with our hybrid model, but I have a plan. I think it's going to work. If we have time, because again, I haven't done this as a half-year course before, but if we have time, I'd really like to get into reverse engineering. If we don't do it this year, we'll do it next year, where students, what I've done in the past, this is an example of, where we give them just an everyday product. This was a math kit. They called it a math kit. It's like a little drafting kit that I got from the dollar store. Students took measurements of every single little part and piece, recreated it in the software, and then what they did as the second part of this project is took all of those parts and used them to design something completely different. So here we have an example of students' work where they designed a board game for which they had rules, and it made sense. And again, just taking something that the idea was increase the value of a product. So that the math kit, I think, was like $1.49. So it was come up with something that's more valuable than the original product, and that's what they came up with in this example. So hopefully we'll have time for this. I have high hopes and ambitions for this year and for this course, but these are the type of projects we're going to be doing. Grading, it's all on them as far as being responsible for completing projects. 60% of their grade is based on projects, 30% are on kind of smaller classwork, and 10% is participation. My extra help, which is posted in Schoology, is Tuesdays during period 3 and after school, and Wednesdays after school. And for this year, students have to email me in advance to sign up for extra help. They're already aware of this, but I wanted you to be aware as well.